Hello, Algebra 2. Here we are with our first lesson of Unit 9, Trigonometry. Alright, the study of relationships among angles and sides of right triangles. We're looking at our SO, CA, TOA. S-O-H, so. We got sine, abbreviated S-I-N on your calculator button. Opposite over hypotenuse, S-O-H, S-O-H. CA, cosine. Okay, cosine equals adjacent over hypotenuse, C-A-H, C-A-H. And TOA, tangent is opposite over adjacent, T-O-A, T-O-A. Alright, one of the big things that will help you be successful in this chapter and in trigonometry is being able to accurately label the sides of a triangle. Okay, so whatever angle you're working with, this is theta. It's like the angle variable, like x is for all the other stuff. We usually use theta when we're talking angles. Okay, that's the angle you're going from. So from this angle across from it is opposite. Okay, always across from the right angle will be your hypotenuse. Always, always, always from the right angle is the hypotenuse. And then the leftover one is adjacent. Adjacent is a big fancy word that means next to. This is the side or the leg of the triangle that's next to the angle we're talking about, but not the hypotenuse. Alright, go ahead and push pause and try your luck on those two. Okay, here's what I had. Opposite, adjacent, hypotenuse. Opposite, adjacent, hypotenuse. Good work. Okay, now we're actually going to do them with numbers. Okay, again, if our theta is in this corner, that means this side is the opposite. Then we have the hypotenuse over here. And that leaves this one for adjacent. So sine is opposite over hypotenuse. So opposite, 5 over hypotenuse, 13. 5 over 13. Cosine, CA, cosine is adjacent over hypotenuse, 12 over 13. And tangent is opposite over adjacent, TOA, opposite over adjacent, 5 over 12. Okie dokie, your turn. You got this triangle on your own. Push pause and give it a go. Alright, here's what I had. 3/5, 4/5, and 3/4. Hopefully you had the same as me. Next we're talking about reciprocal functions. Okay, sine is opposite over hypotenuse. If we flip it upside down, we have hypotenuse over opposite, and that is cosecant. Cosine is adjacent over hypotenuse. If we flip that upside down to hypotenuse over adjacent, we have secant. In tangent, TOA, opposite over adjacent. Let's flip it, adjacent over opposite, and that's cotangent. Okay, with each partner, each set of partners here, one of them starts with an S, one of them starts with a C, and the other one doesn't. Just with these two, it's an S. Okay, so first, cotangent, tangent, people usually don't have a tough time remembering that those two are partners. Okay, sine starts with an S, so its partner will start with a C, cosecant. Okay, cosine starts with a C, so its partner will start with a S, secant. Okay, so we got the definitions of it, like hypotenuse over opposite, or you can just take the sine, cosine, tangent numbers and flip them. So cosecant is hypotenuse over opposite, 13 over 5. or you can just take 5/13 and flip it. These are the same triangles. Alright, secant would be hypotenuse over adjacent, or we can flip the cosine. 13 over 12. And cotangent should be 12 over 5. Alright, your turn to do these three. Again, same triangle. Put theta in that corner. Same triangle as above. Go ahead. Alright, check it out. I got 5/3, 5/4, and 4/3. These should all be flips of their matching partners in the above problem. Next, find the exact values for all 6 trig functions. Okay, let's call this corner theta, the bottom corner. Alright, so from here, across is opposite, and we don't have anything there. So, what do we do if you don't have a side, you're missing a side in a right triangle? You're going to have to do a little a squared plus b squared equals c squared. So we got 5 squared plus, I'm going to go x squared because my b's turn into 6s. So 5 squared plus x squared equals 8 squared. And x squared, after we subtract 25 over, is going to be 39, which means x is the square root of 39. So this is square root of 39. Alright, back to work. So this was the opposite side. This is the hypotenuse. And the adjacent side is over here. Sine, S-O-H for so. Sine is opposite over hypotenuse. Square root of 39 over 8. Cosine, ka. Cosine, adjacent hypotenuse. 5 over 8. And TOA, tangent is opposite over adjacent, radical 39 over 5. Okay, so the reciprocal ones, we're going to flip them, and that's going to flip to 8 on top, square root of 39 on the bottom. And I'm sure your geometry teachers taught you that you can't leave that radical in the denominator of a fraction for your final answer. So we multiply top and bottom by that same radical. And we'll get 8 radical 39 over regular 39. Okay, flipping secant. Okay, cosine to secant, we'll have 8/5. No issues there. Flipping tangent to cotangent, we'll have 5 over square root of 39. Okay, again, don't want that radical. This is 5 radical 39 over regular 39. Go ahead and push pause, and you try the right-hand side on your own. Ready, set, go. Alright, let's see how you did. Okay, your missing side length there was radical 5. And check out those 6 trig functions to make sure yours match. Alright, onward to solving. Using our trig ratios to solve. In the triangle, we have 10 degrees in this corner. Okay, across from 10 degrees is this side x. That is our opposite side. Across from the right angle is the hypotenuse. There's nothing over here. And then the third side is your adjacent. So we have things on the opposite side and the adjacent side. What trig function uses opposite and adjacent? Tangent. So tangent of 10 degrees equals opposite over adjacent, x over 12. All right, we're going to multiply by 12 to both sides. Okay, 12 times tangent of 10 degrees equals x. So we've got 12 times tangent of 10. You don't have to type the degree sign. Enter. Okay, if you're not getting that, you want to check your mode and make sure we are in degree mode. Okay, you'll have to slide over it so the degree is highlighted and hit enter. And then try it again if you didn't get that the first time. Okay, this says to round to 2 decimal places, 0.01. So we're going to look at the third place to decide if you move up or down. This time we do 2.12. Middle problem. Opposite is empty, nothing over there. Hypotenuse and adjacent. That should be hypotenuse and adjacent. That's going to be cosine. Cosine of 20 equals x over 25. Adjacent over hypotenuse. Okay, 25 times cosine of 20. 23.49 for x. And the last one is a fun one. Opposite and hypotenuse. That's going to be sine. So sine of 30 equals opposite over hypotenuse. 5 over x. Okay, x is on the bottom this time. So far, x has been on the top for the first two. And then we just had to multiply by that bottom number. And we had our answer. Now x is on the bottom. Okay, there is a super nice shortcut. I'm going to show you the long cut first. We need x on top, so we're going to multiply by x. Okay, we'll have x times sine of 30 equals 5. Then we'll divide by the sine of 30. Okay, and look what happened. Really, all that happened was x and sine flip-flop spots. X moved up, sine went down. So that is the shortcut for these early on problems. These early trig ratio problems, that if x is on the bottom, you can just flip-flop it with the trig function on the left. And 5 divided by sine of 30 should be 10. Alright, you know the drill. You got the right-hand side on your own. Push pause and give it a go. Alright, let's see how you did. We should have tangent of 65 equals x over 3. Multiply both sides by 3, and we'll get 6.43. Middle problem. Cosine of 15 equals 23 over x. Ooh, x is on the bottom. Do the little switcheroo. X equals 23 divided by cosine. And we should get 23.81. And last we have sine of 20 equals x over 17. Multiply by 17 and we get 5.81. Alright, excellent work there today. You should be good to go now for that worksheet. Let me know if you have any questions. Good luck.